Hello, and welcome to Minotaur Mission Control, live from Vandenberg Air Force Base, California. I'm Sean Wilson, Director of Corporate Communications for Orbital ATK. Today we are set to launch 10 Earth observation satellites aboard a Minotaur C rocket for Planet. You're looking at a live shot of Space Launch Complex 576E and the Minotaur C rocket that will boost the satellites into orbit. Today's targeted launch time is 2:37 p.m. Pacific Time. These launches are managed by the U.S. Air Force's 30th Space Wing, commanded by Colonel Michael Huff. And joining me now is Colonel Michael Huff. Hi, Colonel. Thanks for being here today.
Hello. Thank you very much for having me.
Great. So what is the mission of the 30th Space Wing?
So our mission is to provide indispensable launch, landing, and range capabilities to our nation.
Well, great. So what does this mission mean to you today?
Well, any mission, anytime we have a launch, it's very exciting for the wing. This one in particular, I think since the last time that we had an Orbital ATK launch from Vandenberg was 2011. So this mission is exciting because it's been a while, and we're launching from a pad that we haven't used in quite a long time. So we've been able to get really the whole wing involved. Usually, it's just our launch group or our ops group kind of involved in the launches. And this one in particular, we've been able to get our CE to get the pad ready, our civil engineers, our security, set up new checkpoints to make sure we don't have people back there, and safety's involved as well. So it's a whole wing operation.
Well, that's great. We're happy to be here with you.
Thank you.
So thanks so much for being with us today. We're looking forward to a good launch.
Thank you very much,
Okay.
and I'm looking forward to a good launch as well.
Okay, appreciate it.
Yep.
The weather will play an important role in making today's launch window. So let's get a weather update from Captain Jennifer Hayden from the 30th Space Wing. So how's the forecast looking for today's launch?
Well, the forecast is looking very favorable for launch today. We are currently green for both the launch agency and range safety constraints, and we're assessing a 0% probability of violation, or POV, for T0 itself, with no areas of concern at this time.
At 0%, that's a pretty high probability.
Yes.
That's great. We're always happy to have launch windows like that.
Absolutely.
So if anything changes, make sure you come back and keep us updated.
Absolutely, we will.
Okay, thanks so much.
Thank you very much.
You're watching live mission coverage of the Minotaur C launch of the SkySat and Dove Earth observation satellites for Planet. We are on schedule for launch today at 2:37 p.m. Pacific Time. With me now is Trina Patterson, Senior Communications Manager for Orbital ATK's Launch Vehicles Division. Hey Trina, thanks for being with us today.
Thanks for having me. I'm really excited.
So where do we stand now in the mission timeline?
So right now the count is proceeding. Adam Lewis, our launch conductor, is going through the pre-launch checklist, and everything's right on schedule for launch.
Well, that's great. Great to hear. So mission coverage will continue through the insertion phase of the spacecraft into their final orbits, approximately 20 minutes after liftoff. You can also follow today's mission on Twitter at Orbital ATK or at Planet Labs using the hashtag Minotaur C. We're about 15 minutes from liftoff now. The next major event in the timeline will occur at L-13 minutes when we'll enter a built-in 5-minute hold on the countdown clock. So Trina, anyone that knows you and I, knows that we both live for rocket launches like this.
We do. This is like our favorite day at work. And this launch has been really exciting because we've had a really neat customer and Planet. They've been just fun to work with, so we look forward to launching for them today.
So tell me a little bit about the rocket itself.
Absolutely. So today's mission is our second Minotaur vehicle to launch within 2 months of each other. The last one launched from Florida. This one's from California. We can see here that there are 5 different Minotaur vehicles in the fleet. Minotaur C is the tall, skinny one, second to the right in the graphic. While our other Minotaur rockets uses decommissioned ICBMs in their first stages, Minotaur C uses commercially available Orbital ATK rockets in all their stages, hence why we call it Minotaur C. The C is for commercial. So this is a 4-stage rocket. We have a 0 stage, a stage 1, a stage 2, and a stage 3. I'll explain the 0 stage when we look at some animation later on in the broadcast.
Okay, thanks, Trina. We're less than 14 minutes from liftoff now, and we're about to enter the 5-minute hold period.
And launch team, I can confirm T clock is holding at T-minus 8 minutes. We're currently in our final planned 5-minute hold.
This is Minotaur Mission Control, and we are now less than 13 minutes from liftoff. So, Trina, I understand you have some animation to show us of today's mission.
I do, and obviously this isn't real time, but it'll give a good sense of what's going to happen today during the mission. So at liftoff, the ground stage motor will ignite, boosting the rocket from Slick 576 here at Vandenberg Air Force Base. The ground stage, which for this vehicle we actually refer to as a 0 stage, it fires for about 1.5 minutes. At this point, we perform what's called a hot set test, where the first stage ignites at the same time the 0 stage separates. Stage 1 then burns for about 1 minute and 20 seconds. Stage 1 separates, and the second stage ignites. At this point, we're over 90 miles above the Earth and 200 miles downrange. After that, the payload fairing, which protects the spacecraft during the rocket's ascent, is jettisoned. The second stage burns out about 4 minutes into the mission, and at a little over 5 minutes into flight, that second stage will separate from the rocket and the vehicle stack, and we'll begin to coast for 4 minutes. 9 minutes into flight, the third stage ignites and burns for a little more than 1 minute. This is where we reach our targeted orbit of about 350 miles above the Earth. At about 12.5 minutes after liftoff, the spacecraft deployment will begin. The primary payloads on this launch are 6 SkySat satellites. The first 4 will deploy in 20-second intervals. They are released from what is called the dual payload adapter fitting. You'll hear it during the call as a D-path. After the first 4 satellites deploy, the vehicle will then make a 90-degree turn, jettison that payload adapter away from the orbit of the satellites, and then turn back to deploy the final 2 SkySat satellites. So on this mission, we're also carrying 4 Dove CubeSats, which will be deployed after the SkySats are placed into orbit.
And launch team LC, countdown 1. At this time, I want to perform our final launch readiness poll. Ops 1.
LC, Ops 1 is go.
Vehicle.
LC, vehicle. Minotaur C engineering team is go.
OD.
OD is go.
SE,
SE is go.
SMD,
SMD, go for launch.
LD,
LD is go.
OA,
OA is go.
Spacelift Commander.
Spacelift Commander, clear to launch.
And we are clear to proceed with launch. Check step 150.
As you just heard, we were given the go to proceed for launch. We are now about a little over 9 minutes from launch. So Trina, tell me a little bit more about the rocket itself and how the team goes about getting the rocket ready for launch.
Absolutely. So this is based on our Pegasus rocket, which is launched using a modified L-1011, which we call Stargazer. Pegasus was the world's first commercially developed rocket, which had its debut in 1990. Since then, we have conducted 43 Pegasus missions from 6 different launch sites around the world. For Minotaur C, we add that 0 stage in place of the Stargazer L-1011 to make it a ground-launched rocket. So first, the satellites are mated to the payload adapter and enclosed in the fairing. They are then mated to the rocket's upper stage and transported from the processing facility down to the launch site, which is what we see happening right here. Now this launch pad may look a little bare to some. It has no gantry, so the 0 stage is stacked on the launch stool using commercial cranes, and then we lift the upper stack into place. So Minotaur C was designed just like Pegasus to launch quickly from almost anywhere in the world with minimal launch support equipment.
Final countdown has resumed at T-minus 8 minutes. RCO LC countdown 1, step 152. Begin C-band interrogation.
LC, RCO on work.
This is Minotaur Mission Control. As you just heard, the countdown clock has resumed, and we are go for launch in about 7.5 minutes. So today's launch is for Planet, one of the innovative new space companies in the Earth imaging industry. We have a video about Planet, so let's watch. This is Minotaur Mission Control. We are about 4.5 minutes and counting from launch. From here on in, we're going to listen into the launch net and launch conductor Adam Lewis as he leads the team through the final count.
Copy, vehicle. Ops 1, step 167. You go to rotate SNAs to arm. Enable stage 0 PDU.
LC, Ops 1, in work. FTS armed. Vehicle armed. LC, Ops 1, VIC indicates all armed and ignition enabled.
Copy, Ops 1, check 167.
LC vehicle and FTS are armed.
Copy that, vehicle, check 168. ROC, send range status and alert signal and verify. And Rock LC, countdown 1, your go for step 169, send range status and alert signal and verify.
LC, Rock, range is green.
And I copy range green, check 169.
L minus 3 minutes and counting.
And Ops 1 LC, countdown 1, step 171, mode SIGI to nav.
LC, Ops 1, in work. LC, Ops 1, SIGI in nav mode. Time is 21:34:45.
LC vehicle, SIGI in nav mode. True heading is 120.597. SIGI is nominal and green.
Copy all, vehicle, check 172. And Ops 1, your go to initiate countdown to auto sequence startup at T minus 1 minute, 30 seconds.
LC, Ops 1, in work. LC, Ops 1, countdown initiated.
Copy that, Ops 1. T minus 1 minute mark.
LC
L
vehicle,
minus 1 minute.
auto sequence start.
Copy auto sequence start.
Electrical, PDUs, and ODMs enabled. Vehicle fully armed.
Copy electrical 1. T minus 30 seconds. Mark.
Go Minotaur C, go planet.
Stage 0 TV squibbed.
T minus 10 seconds. Mark.
L minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of Minotaur C carrying the SkySat and Dove satellites for planet.
Attitude is nominal. Attitude remains nominal as the Castor 120 Stage 0 motor propels the 104-foot tall Minotaur C vehicle away from Vandenberg Air Force Base. Stage 0 motor pressure is nominal. Attitude remains nominal. Stage 0 TVA is performing nominally to control the flight of the vehicle. Vehicle is past max Q, attitude remains nominal. Now approximately 50 seconds into the Minotaur C mission for Planet to place 6 SkySat and 4 Dove spacecraft into a sun-synchronous orbit. Attitude remains nominal, coming up on Stage 1 TVA pressurization. Stage 1 TVA has been pressurized. Stage 0 has burned out. Stage 0 separation. Stage 1 has ignited and attitude is nominal. Stage 1 TVA is nominal and controlling the flight of the vehicle. Power buses remain strong at 100 seconds into the mission. Now 2 minutes into the Minotaur C mission for Planet. Attitude remains nominal as the vehicle altitude passes 100 kilometers. And we have lost telemetry in the center. We have negative telemetry in the center.
Seen STM. Yes, we still have lock on range data. Yes, so we have can work.
And ROC, this is vehicle on countdown 1. We have negative telemetry in the center here at building 836. Was just hoping you could confirm the track of the vehicle via radar.
And this is the rock.
This is vehicle on countdown 1. We have recovered telemetry in the center. We are now 230 seconds into the flight. Attitude remains nominal and we're in stage 2 burn. Stage 2 burnout. Vehicle energy state is good. Fairing has separated. I repeat, the fairing is confirmed to have separated and fully deployed. Vehicle is now in a prolonged coast phase as the flight software of the Minotaur C vehicle waits for the vehicle altitude to reach our orbit injection point of approximately 500 kilometers. And once again, we have negative telemetry in the center. Okay, this is vehicle on countdown 1. We have active telemetry in the center once again. Now over 300 seconds into the mission. All systems are operating nominally.
This is Minotaur Mission Control. We have had second stage motor separation. The rocket stack has now entered a 4-minute coast phase. Liftoff was at 2:37 p.m. Pacific Time. I'm joined now by Chester Gilmore, Vice President of Manufacturing for Planet. How about that launch?
That was amazing.
Yeah, great. Well, thanks for being here. Can you tell me a little bit about how the SkySats are built and who the major players are that are involved?
Yes, absolutely. The SkySats are built with a whole lot of awesome. The major players would be obviously the tremendous efforts from the engineering team at the formerly Terabella and Skybox team, who actually engineered the bulk of the work, and then the payloads are built by L3, and the propulsion modules are provided by ECAPS, and it's actually very interesting. It's a green propellant system on board these SkySats, and the final assembly and test integration and launch campaign is supported by SSL.
Okay, great. So can you tell us what kind of testing the SkySats undergo prior to launch?
Oh yeah, we do all the testing.
All the testing.
All the testing.
So I understand you have 4 Dove CubeSats on this launch. So how do the 2 satellite fleets complement each other?
Yes, absolutely. If you think about the real plan for the product in the future, what Planet is building is really information about the changing planet. So we think of this like a queryable Earth, where you can go to our platform to ask questions about the planet and find answers. If you think about the different classes of spacecraft, they would operate much like the human eye operates. So if you think about the human eye when it's looking at a wide field, you have your peripheral vision, which are the Dove satellites, providing a base layer of about 3 to 5 meters resolution. And then when you see something of interest, you would turn your head and your iris would zoom in and focus. And that would be what the SkySats would do. So the theory is to operate them as a homogeneous network of spacecraft.
Okay, that's really interesting. Yeah. So I understand you've launched many times in the past. So what makes this specific launch so unique?
Well, this has been a lot of fun. In the past, we've always been secondary, which means we're somewhere in the trunk of the rocket, not paid much attention. And this has been our first dedicated rocket launch, and it's actually our first time we've been involved in mission control and the launch operations. So it's been a tremendous amount of fun.
Well, that's great. Glad we can provide that opportunity for you. So tell us a little bit about the art that's on the rocket fairing.
So the art on the rocket fairing was provided by our artist in residence, Forrest Stern, and it depicts several concepts. The first is an image of a dove, which represents the Dove class spacecraft. And then in addition to that, there's an image of a macaw parrot, which is meant to illustrate the SkySats, a much larger macaw parrot. So all of the spacecraft that we've launched to date, including the Doves, have all actually had art etched onto the side panels of the satellite. So art's something that's very important to us at Planet, and we hope to continue.
That's great. So can you tell me, excuse me, how Planet's customers use your imagery?
Absolutely. So we have a very, very wide customer base. There's the traditional consumers of pixels or satellite imagery, which would be agricultural resellers or the government. And then we have a newer class of customers who are more interested in insights that they can provide out of the data. So they're not taking the geotiffs or taking the raw pixels, but they're looking for answers. And those might be hedge funds, insurance companies, people who are utilizing our platform to develop applications to do automated road detection. So a good use case of that would be after a disaster is struck. First responders could use the platform to figure out, okay, where are there actually roads still, so we know where to send aid.
Oh, that's really great. Thanks so much for being with us here today.
Absolutely, my pleasure.
Yeah.
Thank you.
Looking forward to deployment.
Absolutely, yeah.
Yeah.
Fingers crossed.
Fingers crossed. All right.
Yeah.
Thanks.
Thank you.
Attitude remains nominal during stage 3 burn, and it appears that we have gone over the radio horizon and lost telemetry for the last time on the mission. And this is vehicle on the countdown net. The data that we're seeing now in the center is a simulation of the predicted activities of the vehicle. So although the vehicle is over the horizon and we have no telemetry coverage, this graphic will allow us to continue to watch the expected events as they unfold. Vehicle at this time would be in orbit and preparing for deployment of the 6 SkySat spacecraft.
We are about 2 minutes from the main event, the deployment of the SkySat satellites. With me again is Trina Patterson. So Trina, where are we? Give us a little update on where we are.
So the vehicle has actually traveled over the horizon. So what you are seeing now is simulation. So if you remember from the animation earlier in the show, prior to launch, the first 4 satellites will deploy about 20 seconds from each other. And again, these are the Planet SkySat satellites. And then the vehicle will make that 90-degree turn and release that payload adapter. And that just gets it away from the orbit of the satellite, so there's no collision. And once that's been released away, the vehicle will turn back. And this happens about a minute later. And then those last 2 SkySat satellites are deployed. Approximately just a little over a minute, the 2 Dove satellites are deployed, followed by those last 2.
So in this video, these Dove CubeSats look pretty small. So about how big are they?
They're actually the size of a loaf of bread. They weigh 9 pounds, so they're fairly small. It's amazing what miniaturization of satellites has done to the technology.
So the maneuver that the vehicle does to deploy the satellites, is this common on most launches?
It is common when you're carrying multiple spacecraft like this. So we're able to have those dual levels to be able to support that.
Mm-hmm. And how do you turn the vehicle like that?
So we use very small thrusters to make those precise turns. If you notice, those turns are like in a minute and a half, so it's very important we get it into the right orbit. We also use those thrusters to back the vehicle away when we're done deploying all the satellites.
Okay, thanks, Trina. Let's listen in as Steve Hollow goes through the planned calls of the satellite deployment.
We're now approximately 20 seconds away from the expected deployment of the first SkySat spacecraft. First SkySat spacecraft would be deployed this time. Following spacecraft are all on 20-second intervals. Expected deployment of SkySat SS-12. Expected deployment of SkySat SS-11. Expected deployment of SkySat SS-10. Following deployment of the first 4 spacecraft.
So Sean, at this point in the mission, this is where we turn that vehicle. You can see those little thrusters too as it's moving. Again, this is a simulated of what we are projected to happen right now. And so we'll turn that, release that bulkhead. You'll hear the launch conductor call it the D path. They turn it away from the orbit of the satellites, and then we'll turn it back. Again, this is to avoid any collision with the satellites in their orbit.
Thanks, Trina. Let's listen in to Steve Hollow as he makes those calls.
the expected deployment of the forward bulkhead. And with that deployment, the vehicle will return to the velocity vector to deploy the final 2 SkySats.
So we have about 1.5 minutes where we will rotate the vehicle back into that alignment of orbit to release the final 2 SkySat satellites. Now, Sean, this is the real exciting part of the mission. When we're deploying those satellites, we know we're putting them into the orbits and they're going to be operational for Planet.
Yeah, that really is exciting. Thanks, Trina. Let's listen in to Mission Control as we await those last 2 satellite deployments.
And now approximately 20 seconds away from the deployment of the 5th SkySat spacecraft. Expected deployment of SkySat SS-9. Expected deployment of SkySat SS-8. That's all 6 spacecraft expected to have been deployed. The vehicle is now reorienting itself in preparation for deployment of the first of 4 Dove spacecraft.
As you heard, the 6 SkySat satellites are now in orbit, and we await the deployment of the 4 Dove CubeSats. So, Trina, is it common to launch this many satellites on one rocket?
It is, Sean, to actually launch multiple payloads. In fact, on one of our Minotaur 4 rockets, we launched 20 satellites. And I just learned this week that Planet has launched 88 Dove satellites in one mission.
One mission?
One mission.
So if they've launched 88 in one mission, how many do they have total?
So they have manufactured 300 of them. They've launched 284. So today's mission will actually have 4 more to add to what they call the flock.
Wow, that's a lot. So let's listen in to the call of the Dove deployment.
Expected deployment of Doves 1 and 3. Vehicle is reorienting again for the deployment of Doves 2 and 4.
So the first 2 Dove satellites have deployed. The last 2 will be in orbit in about 1.5 minutes. Now these satellites, if you heard from Chester, they image the Earth constantly. The Dove satellites can go to about 3 meters pixels, so basically the size of a car. It really complements the SkySat, which can go a lot higher resolution. So they get really good imaging out of these spacecrafts we're launching today.
Thanks, Trina. Let's listen in as we do the deployment of the final 2 Dove sats.
Approximately 20 seconds until the deployment of the Doves 2 and 4. Expected deployment of Doves 2 and 4. This would conclude the Minotaur C mission for Planet to place 6 SkySat spacecraft and 4 Doves in a sun-synchronous orbit. First contact of the SkySat spacecraft is expected at approximately 1300 UTC, or about an hour from this point forward, so stations shall remain on console until that time.
And there you have it, the completion of the Minotaur C launch of the Planet SkySats and Dove Earth imaging satellites. A special thank you to Chester Gilmore from Planet for being here, and Colonel Huff and Captain Hayden from the 30th Space Wing for joining us. And of course, a special thank you to you, Trina, for taking the time to explain the rocket and for being here with us today.
And thank you, Sean, for being here. It's been a great launch and a great way to watch it with you. So I want to also give a special thanks to the incredible team here at Vandenberg Air Force Base for their support of this mission, and to our Planet customer for giving us the opportunity to launch their vehicle to their orbits today. And a very special thanks to all of the Orbital ATK employees whose dedication ensures mission success. In fact, Sean, this team, a lot of them will be traveling to NASA Wallops Flight Facility next week to launch our Antares rocket and Cygnus spacecraft carrying cargo for NASA.
So it's a busy time for launch vehicles.
It's a very busy time for us.
And that launch is going to be broadcast on NASA TV, correct?
It is. It will be on NASA TV on November 11th.
Okay, that's great. Thanks so much.
Thank you.
So for updates on all of our upcoming missions, please follow us on our website at orbitalatk.com or on Twitter at orbitalatk. We'll leave you with another look at liftoff of the Minotaur C rocket from Slick 576E here at Vandenberg Air Force Base, California. Thanks for watching. L-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff of Minotaur C carrying the SkySat and Dove satellites for Planet.
Attitude is nominal. Attitude remains nominal as the Castor 120 Stage 0 motor propels the 104-foot tall Minotaur C vehicle away from Vandenberg Air Force Base. Stage 0 motor pressure is nominal. Attitude remains nominal.